For this part of the video, we are looking at simplifying trig expressions. We're going to look at problem 8-167 from the closure. You could also do, if you look at the side from the team review, problem 5A and B covers the same concepts. Now, if we're looking at this simplifying, we have all these different ways of simplifying. Yes, we have those Pythagorean identities, we have the formulas, and we may apply those. But we also have to realize all the other techniques we learned how to simplify before we dealt with trig expressions. And so, in other words, if I'm looking at part A and I have sine of x plus sine of x times cotangent squared of x, I need to find how can I simplify this. And when I look at this, I see I have two terms. So I have a term, a term on the left of the plus sign, a term on the right side, and they both have a sine of x right here and right here. So I can apply factoring techniques. I can really apply the GCF, the greatest common factor. And I can factor out a sine of x from both terms. And that's going to leave me with a 1 plus cotangent squared of x. And so we have this all set for us. That sine of x, I can't really do anything with it. So I'm going to take that blue and I'm just going to leave it to the side. I'm not going to change it. I'm just going to go and put it down here. Now, when I look at this one, where I have 1 plus cotangent squared of x, I see a squared trig expression, so part of me is going, maybe it's one of those Pythagorean identities, especially because I see a plus and a 1. So I have to go through my mind, okay, what is it going to be? And if I'm right, I believe that this is cosecant squared of x. And so now I have that, and that's great. You may go, okay, well, I'm done, because I did a GCF and I did Pythagorean identity, so I should be done, and you're not. Because I can simplify cosecant squared. I still have my sine of x. And another way of writing cosecant squared of x is to write 1 over sine squared of x. Now the reason why I'm doing that is I'm getting in the same language, sines. And I can see that I can cross out one of these with one of those. And so really I'm left with, and I'll put it right over here, 1 over sine of x. And again, you may go, well, that's done. But it's not, because it's a fraction and it's got a sign at the bottom. I can write it so it's not a fraction by using a reciprocal, cosecant of x. Now that is your final answer. So this whole thing turns into cosecant of x. So we applied GCF, we applied Pythagorean identity, we also applied a reciprocal, and we simplified. So keep those techniques in mind. Now if I look at part B, there's a few ways of doing this. There's ones that are more obvious for people, and there's ones that aren't too obvious. I'll show both of these. What's really interesting is the way I did this is I saw right away, and I'd say it's the obvious, I'd go, oh my goodness, 1 plus cotangent squared. I believe we just looked at that over here, didn't we? 1 plus cotangent squared of x. So that together can give me, combined, a cosecant squared of x. And that's what I did, if you look at my answer key. And if I have this one right here, cosecant squared of x times cosine squared of x. And what's really interesting is it uses the same technique as part A down there. Is I see I have a cosecant squared to the left of the minus sign and a cosecant squared to the right of the minus sign. So I can think about applying factoring techniques and take out the greatest common factor, which is a cosecant squared. So I can factor out a cosecant squared of x, just like I did in part A. And that's going to leave me with a 1 minus cosine squared of x. Well, then I have a squared trig expression. I have a 1 there and a minus. So again, something's, I'm thinking Pythagorean identity here. 1 minus cosine squared. Well, that is sine squared. So I have a sine squared of x, and it's being multiplied by cosecant squared of x. Now, if I can realize right now that those two are exact reciprocals, one's sine squared, one's cosecant squared, which is 1 over sine squared. And if you multiply something by a reciprocal, you're going to get 1. And if I can realize that, I could jump right down to 1 for my answer. If I don't realize that, I have to go to a common language, which would be sines. And so I'd have 1 over sine squared times sine squared of x. And you can see both of those cancel, and I'm left with 1. And now we're on trig ratios for the unit circle. And I'm going to actually phrase this a little bit differently. I'm going to say trig ratios for right triangles. because that's really what you're looking at. We're going to do basic and reciprocal, and that means sine, cosine, tangent, basic trig. And then we're going to do reciprocal trig, cosecant, secant, cotangent. You can see there are a lot of problems that you've had recently. You have a few on the closure, you have one on the starter, and you have one on the team review. We're going to do one problem from the closure, and we're going to do problem 3 from the team review. So we're going to be doing part A of 170, and we're going to do number 3 from the team review. Now, pay attention to reading the directions, because it does say determine the exact value, which means you're not looking at decimals, you want the exact value, and the advice says draw a triangle. So that's the big key, draw the triangle. So the way we're going to do 170 is really going to help us with that team review number 3. And in 170, let's just start off. Find cotangent of x. So I know this is my end game. I want to know, what does cotangent of x equal? That's what I want to know. Well, what does it equal? Well, let's kind of think about what we know. We know cotangent is the reciprocal of tangent. Tangent, if I'm dealing with right triangle, because it says draw the triangle, if I'm dealing with right triangle trig, tangent is opposite over adjacent. Which means that if I'm looking at the reciprocal, the cotangent is just that fraction flipped, adjacent over opposite. So now I know when I'm drawing a right triangle, I need to know my opposite side, I need to know my adjacent side. And what am I being given? Well, I'm being given the sine of x equals negative 1/2. Remember, sine means opposite over hypotenuse. I'm also told that it is in quadrant 3. So when I draw it, I'm going to draw it in quadrant 3. So I'm drawing my right triangle. I'm told the opposite side is a negative 1, and the hypotenuse is a 3, 4 angle x right there. Well, if you look, man, for cotangent, I know my opposite side right away. It's negative 1. No real work needed. Great. But how do I find my adjacent side? Well, that would be the Pythagorean Theorem. I would say, okay, well, a squared plus negative 1 squared equals 2 squared. So that means a squared would equal 3, and when you square root, you do the plus or minus sign. So which one is it? Is it positive or is it negative? Well, we're at the negative x's, so it's a negative radical 3. So if cotangent is adjacent, which is a negative radical 3, over my opposite, which is a negative 1, I have my answer. I have cotangent of x, a negative divided by negative is a positive, and we never show divide by 1, so the answer is radical 3, and that's it. Before we move on to the next one, actually we'll move on to the next one, because one thing that didn't happen here that we'll see in the next one is how do I rationalize in certain cases. So the big thing with this is draw the triangle. I know negative 1/2 is in the unit circle, and you might be able to do it that way, and that is awesome. However, there are a lot of ones that are not going to be in the unit circle, and we're going to have to draw it out and then just do our right triangle trig. So if we look at this one, that's what we're going to be looking at. So this is from your team review, number 3. And by the way, notice it's actually set up the same way. That's pretty nice, so I don't really have to do all the work. I'm going to go ahead and copy what I had for the other one, because I'm told the sine of x is negative 1/2, and I am in quadrant 3. So really, it's the same exact setup. And so we can kind of have the main idea. So while you're kind of writing this down, I'll say, you're going to draw the triangle in the quadrant. You're going to label the signs positive or negative for left and right, up, down, based off of the movement in the x-axis. And both of those, you're going to left, so that's a negative x, down, so that's a negative y. If you're missing any sides on a right triangle, you can use Pythagorean Theorem. I now, hope you had a copy down by now, have everything I need to do right triangle trig, which means sine, cosine, tangent. So notice I gave you sine, so let's go ahead and do cosine. Cosine's adjacent over hypotenuse, so that's negative square root of 3 over 2. Tangent is opposite, which is a negative 1, over adjacent, which is a negative radical 3. So there's the first problem. We cannot have a negative in the denominator. And by the way, a negative divided by negative is a positive. So I'm just going to get rid of those right away. So in this case, what I'm going to do is I'm going to rationalize. I'm going to multiply by a clever form of 1. multiply by radical 3 over radical 3. Because these two are really going to cancel out the radical. I'll get radical 9, which gives me just a 3 on the bottom. And then 1 times radical 3 is radical 3. So there's the basic trig. Now we're going into the reciprocal trig, which really is what we've done before. Cosecant is the reciprocal of sine. So I'll just put it down here. So that means if sine is opposite over hypotenuse, then cosecant is hypotenuse over opposite. So that would be 2 over negative 1, which is just negative 2. Secant is going to be the reciprocal of cosine. So secant is going to be hypotenuse over adjacent. So let's see, our hypotenuse is 2. Our adjacent is negative square root of 3. So what am I going to do in this case? Well, in this case, if I want secant, I have a radical at the bottom, I'm going to have to rationalize it. I'm going to multiply by a clever form of 1. Now, I'm going to really ignore that negative because negatives really go up to the top. So I'm going to have a negative 2 radical 3 over 3. Now, cotangent is the reciprocal of tangent. What's nice, by the way, is this. I could use this, or I could use this. And I'm going to use the 1 over radical 3. Because if I flip that, I just get radical 3. If I flip the other one, I'm going to have to rationalize and then simplify. But if I flip this one, I go right to my answer right away. So that is how we do these. You have to really get in mind a couple things. Is right triangle trig, which we discussed in the previous problem, and the idea of what do reciprocals mean. And so if I know what sine means, cosecant is just that idea flipped. If I know what cosine means, secant is that one flipped, etc. So that deals with unit circle, trig, basic, and reciprocal ratios. So in this problem, we are looking at simplifying rational expressions. Now, you could look at the starter problems. We have ones that deal with multiplication on there. I'm going to focus on problem 166, part C only. And part D, you can see, is another one. And part D is straight multiplication. Part C is division, which means we're going to have to flip and multiply anyway. So if you can do part C, you should be able to do part D. So let's go ahead and dive into it. And this one is more complicated than the other one. It's because there's multiple techniques that you need to use. So when you're dealing with this, the idea is to simplify everything first, but this means I'm dealing with polynomials, I need a factor. So I'm going to factor each part of the expression. So 4x squared minus 8x. Well, when you're factoring, the first thing is to make sure if they have anything in common, you take it out. And these have a 4x in common. So I can factor out a 4x and give myself x minus 2. Now on the denominator, I have x squared minus 9, and that is a difference of squares. So that's x plus 3, x minus 3. I'm dividing, which means I'm going to flip this fraction and I'm going to multiply. Now when I'm doing that, I'm going to make sure I factor them at the same time. So the 2x cubed minus 8x squared is going to go on the denominator. And in that case, it's really the same idea. Well, they have a 2x squared in common. So I could factor out a 2x squared and be left with x minus 4. And the x squared minus x minus 12, well, that's going to factor into the, let's see, x minus 4, x plus 3. And so I have x minus 4, x plus 3. Now, before I start kind of canceling out here, a couple things. One, I can only cancel it out because every operation is either multiplication or division. If there was a plus sign separating any of these in between, then I could not just cross out. I'd have to distribute and combine like terms. And so in this case, I'm allowed to because everything's multiplication. That's the only time you're allowed to cross out. Second, if you're ever stuck with the factoring on what do I do, at least try and get, there's 4 things that are factoring, at least try and do one of the ones that you know how to do. And that way it might give you a guide on what might cancel out. So like, for example, I had x plus 3, x minus 3 here. So maybe that means I might get an x plus 3 or x minus 3 on top somewhere. And look at that, I did. So I can use other factors as a guide to help me factor something I'm struggling with. So now let's cross out. I have an x plus 3 that can cross out. I have an x minus 4 that can cross out. Really, by the way, I also have a 4 on top and a 2 on bottom. So 4 divided by 2 is really 2. And I have an x on top and an x squared on bottom. So this x will cancel, and I'll just be left with an x on the bottom. So on the top, I have a 2 and an x minus 4. On the bottom, I have an x and an x minus 3. And so that is how we deal with simplifying a rational expression with either multiplication or division. So again, I did the division problem because you had to flip and multiply anyway, so it was one extra step. But the main idea is to factor, cross out any common factors, and if you're struggling with factoring, use one of the other parts of the fraction to help you out. So I was asked to do one on transforming functions, and this is really similar to the idea of how we transform anything, the ideas of a, h, and k. And in this case, I only have h's and k's, because I'm given this graph is my f of x. And I'm being told I want to transform that, and g of x is the transformation of f. And it says, hey, take that function and apply this transformation to it. You have f of x minus 3 plus 1. So I really have to think, what is my h and what is my k? And in this case, my h is 3, which means I'm going to go to the right 3 units. And my k is 1, which means I'm going to go up 1 unit. So every point on my f of x graph is going to go to the right 3 units and up 1. And really, I have two shapes. I have a ray, and I have part of a parabola, a piece of a parabola. So before I start doing this, I want to draw your attention to 8162, which should be above this one on your closure packet. Is that one mainly deals with graphing a piecewise function. And looking over the review preview things that have been submitted, is some of you are still struggling with graphing piecewise functions. So I encourage you, look at how I did it on the solution key. I color-coded each part of the piecewise function so you could understand what's going on. So make sure you look at it, because I'll tell you it is something that will be assessed later on, not this chapter 8, but it will be assessed later on. Hint on that one. So really, I'm going to take this ray, and this ray looks like I have a point at -3, -5, but I really want to take that point at -3, -5, and I want to go to the right 3 units and up 1 unit. It has a starting point, a closed circle, at -1, 1. I want to take that point at -1, 1, and I want to go to the right 1, 2, 3 units, up 1 unit. And that is the ray completely set for us. There is the ray transformed to the right 3, up 1. The next part, and I'll use purple for this one, is the parabola. Notice it starts with an open circle. And that open circle is at -1, 1, but again, I want to take that open circle, I want to go to the right 3 units and up 1. Now notice, by the way, that open circle is 2 units above the closed circle. If I go back to the original, notice that this open circle is 2 units above the closed circle. They follow the same transformation. So the distance isn't going to change because I did not have a stretch factor. I did not have an a. So now if I look at the next point I'm going to use is probably my vertex, because it is a parabola, so it's an important point. That's at 0, 0. So if I start at 0, 0 and go to the right 3, up 1, that would put me right here. And the next point I'm going to use, it looks like it has a point at 2, 4. So rather than plotting my point at 2, 4, I'm going to go to the right 3, 1, 2, 3, and I'm going to go up 1. And so there is the end of the parabola towards the direction where you're going to point the arrow. So it curves down, and then it curves up following this way, and then I have my arrow. And so that is the transform function. It's really AHK, which we're kind of used to doing when it comes to trigonometry graphs, following a map. When you do this one, though, you're just doing HK. You follow the same exact idea. So that is transforming a function. So I saved the vectors to the end. We are looking at algebraic, and we're looking at modeling. Algebraic is when I give you the vectors in standard form, and we perform scalar operations on them. Maybe we add, subtract, and we still find magnitude and direction. But I give you the vectors in standard form. That's problem 165 A and B, which is what this video is going to start off with. The next part with vectors on the test is dealing with modeling. And that's dealing with the idea of maybe bearings or dealing with forces. And so that one's a little more complex. And so we'll spend some time. Now, there's two of them that you've experienced, one on the closure and one on the team review. In this video, I'm going to go over question 4 from the team review. It's more complicated, more applicable, maybe, to what you're going to be expected to do. You can look at 168. There's more complications on number 4 to address before you take your test. So let's just dive right into 165 A and B, and I would have my calculator ready because there's going to be some large numbers that we're dealing with. So if I'm looking at this, I want to find, well, what do those two vertical bars mean? And those vertical bars mean magnitude. So I want to find the magnitude of 3 times vector v minus 7 times vector w. So let's do vector v in green. So I'm going to do 3 times vector v in green. So that's just scalar multiplication. I'm going to distribute that 3 to the negative 6 and the negative 1, which is going to give me a negative 18 and a negative 3. So that's the first part. I'm going to, for me, I like to combine that minus sign and treat it like a negative 7 that's being distributed. And so I'm going to say I have negative 7 times vector w. So negative 7, scalar multiplication to 8, negative 9. And that's going to give me negative 56 and 63. Those two are going to be combined. Now be careful. I used the negative 7. So if I distribute the negative, that means I'm just going to add those two together, because adding a negative is subtraction. So my vector is negative 74, 60. And so that's the vector I'm dealing with. But I want the magnitude of that vector. And what does magnitude mean again? What is it? You've dealt with magnitude since you've been in middle school when you first learned the Pythagorean Theorem. Magnitude is the length of that vector. So if I'm looking at this, I'm going to the left, negative 74, and I'm going up 60. It's saying, hey, what is that length? And well, to do that, think about a right triangle. Boom, 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 boom. I would be able to use, I'm so going to make that attach better. There we go. I'm going to use negative 74 here. I'm going to use 60 here, and I can do the Pythagorean Theorem because that's going to allow me to find that length. That's magnitude. Magnitude is the hypotenuse of the right triangle for the vector. It's the force of the vector. It's the length of the hypotenuse. And so I'm going to do the magnitude equals, and here it's just the square root of negative 74 squared and 60 squared. Let's pull up our calculator because there have been some issues in the past still. When you're typing these in, it's going to be dealing with the square root, but negative 70 needs to be put in a parentheses. So negative 70 parentheses squared plus 60 squared. And it's something so basic, but it's something to keep in mind. That's why you need to learn how to write it properly. That way you can learn how to type it in properly. And so if I do that, I'm going to get about 92.2. And so that is going to be my magnitude. My magnitude is approximately 92.2. All right, so that's part A. All right, so part B is asking something different. Part B is asking us to take 6w plus 2v and find the direction of that. So I'm going to zoom out, and I have 6w. So 6w would be 6 times 8, negative 9. And I'm going to add 2v, 2 times negative 6, negative 1. All right, so that's what it's asking me to do. 6w plus 2v. Find that vector, resultant, and then find the direction, which means I'm probably going to want to graph that. So let's see, I have 48, negative 54, plus negative 12, negative 2. And that gives me 36, negative 56. So that is my resultant if I was dealing with a story problem. That is what they're going to add to. I'm being asked to find the direction. And in this case, I need to plot 36, negative 56. Well, that would be in the fourth quadrant. So I'm going to go 36 to the right, and I'm going to go down 56. And so since I'm going down, that's going to be a negative 56. So we can see how the signs hold to be true. And I'm being asked, hey, find the direction. And you keep in mind, and this is going to be the big thing with the story problem, is direction is always from standard position. So when I want to find the direction, I want to find as if I'm measuring from 0 degrees. I need to make sure I do it from there. But the issue is, what I have this triangle. So what I'm going to do is I'm going to find the reference angle in that triangle. And I'm going to use tangent because that's opposite and adjacent. So when I want to find an angle, I do the inverse. So the inverse tangent of negative 56 over 36. And that's going to give me the reference angle. So I'm going to go to my calculator and I'm going to take a look at it. Now, I have a nice calculator because it tells me right away something and I'm going to ignore it. Just so I can show you. Secant tangent, 36 is the x, negative 56 is the y, so it's going to be negative 56 divided by 36. And I get negative 1? That doesn't make sense. Negative 1 degrees does not make sense. And here's the reason why. My calculator is in radians. And so you need to make sure, because when we're dealing with pi, we're dealing with radians, but in this case, I'm dealing with degrees. So I'm going to go to mode, and I'm going to go down, and I'm going to change this over to degrees. And I'm going to hit enter. And now, if I type the same exact thing in, I would get negative 57 point, we'll say 3 degrees. Now, the reason why this one's negative is because I'm starting here, and I'm going clockwise, which is a negative angle. So this is negative 57.3 degrees. And we really just say, hey, the triangle has a 57.3 degree angle. Well, then how do I find my direction? Well, my direction is starting at 360 degrees, and it's going clockwise. I'm subtracting 57.3 from 360. So I have 360 degrees minus 57.3 degrees. In that case, I'm going to get 302.7 degrees. And so my final direction is going to be 302.7 degrees. And that does make sense because that is in my fourth quadrant, which is where my vector is located as well. So keep in mind, direction is always measured from standard position, from 0 degrees. Really important when we start doing our modeling problem, which is what I'm going to go to next. All right, so number 4, we're looking at a 747 flying 387 miles per hour, and of course that's 30 degrees west of due south. So remember what that means. Start south, and then you're going to go west from there. And I'll look at that picture. Then, as it's flying, it goes into a crosswind that is blowing 34 miles per hour due north. So that's nice. It's just going north. Determine the resultant. So I need to find both vectors from the forces, and then I need to add them together because that's going to give me my resultant. Then the speed of that, well, how do I figure out the speed of a resultant? Well, that's the magnitude. So if I can find the resultant and graph it, that's going to give me my magnitude. Well, if I'm graphing it, I should be able to find the direction as well, just like we did before. So first, let's look at what we're going to have, which is the first scenario. It says that we are 30 degrees west of due south. And so I'm going to go south, and then I'm going to turn west 30 degrees. And so many people at this point, they go, all right, so I'm going to do the vectors with force, with my speed, 387, they might say cosine of 30, and 387 sine of 30, and that's wrong. And the reason why is because you are in the third quadrant, and direction is always measured from standard position. And so if I think about it, what I really want for this vector is I want what is this direction. The idea is right. I am going to have 387 cosine of something for my x value, and I'm going to have 387 sine of something for my y value for my vector, but it's the angle that is different. Now, in this case, we just got to figure out, well, what is that angle? Well, I know this is, I can think of this as this being 270 degrees, and I'm at 270, and I'm moving, subtracting, because I'm going clockwise. I could say, hey, you know what? That's 240 degrees. If I don't like using the y-axis, because I don't like using the y-axis, you don't have to use the y-axis here. Because we know west and south make a 90-degree angle, which means that if that's 30 degrees, this is 60 degrees. So I could do 180 plus 60 as well and get 240. And that's going to be what we're looking at. So I'm going to find this vector first. Make sure when I type this in, I have the right setup and it is in degree mode, so I'm good. So I'm going to clear this out. I have 387 cosine of 240. And then I have 387 sine of 240. And if I type both those in, I get negative 193.5. So this vector is negative 193.5, negative 335.2. Should make sense because that is in the third quadrant. So that's the first vector. The second vector says, hey, there's a crosswind blowing 34 miles per hour due north. So if I draw this one, I mean, it's just due north. And I have the speed of it. And so due north, what is that? Well, that's 90 degrees from standard position. And my speed is 34. So this setup is going to be my speed, 34 cosine of 90 degrees, comma, 34 sine of 90 degrees. And I'm not going to use the calculator for this one because it's on the y-axis. So if I think about that point is 0, and the sine of 90 is 1 for the unit circle, and so this would be 34 times 1, which is 34. So those are the two forces. I've separated them as their own, and that gives me each vector. And what I'm going to do is I'm going to combine these two vectors together. And that's going to give me my resultant. If I want to find the resultant, I'm going to take my negative 193.5, negative 335.2, and I'm going to add the 0.34. Add those two together. Well, the 34 is not going to be bad. Well, the 0 is not going to be bad. Negative 193.5, comma, and I believe this one's going to be negative 301.2. If not, I'm just going to leave it that way, so I'm going to type it in the calculator. So here's what we have. That is my vector. That is not the speed of it. That is not the direction of it. The problem wants the speed. The problem wants the direction. But I need that to do it. And I also need to graph it to be able to do it. So I find my resultant not so I have the answers. I find my resultant so I can find the answer. So when I'm looking at this, that is a negative x and a negative y. So I'm going to plot those. And if I plot those, what I'm going to have is I'm going to go to the left, 193.5. And I'm going to go down negative 301.2. And so I'm going to draw that vector. And I'm going to draw the right triangle that's associated with that vector. So this is negative 301.2. Well, how do I find my speed? Well, speed is the magnitude. Speed is the length of the vector. Well, how do I find that? Well, I find the speed with the magnitude, which is the Pythagorean Theorem. So for my speed, I'm going to do the square root of negative 193.5 squared plus negative 301.2 squared. And again, just going to type that directly in the calculator, making sure that I put my negatives inside parentheses. And by the way, I'm just not going to type the negatives. The reason why is because when you square a negative, it's the same as squaring a positive. So 193.5 squared plus 301.2 squared. And that will give me my speed. I'm just going to say it's about 358. So the speed is about 358 miles per hour. Done. Now the next part says to find the direction. Again, direction is measured from standard position. I want to know that angle. That's the goal. I want this direction. The problem is all I know is this part. I know just the theta inside that triangle, which is okay Because if I can find that, I know this is 180 degrees. And if I add that on to 180, that's going to put me in the third quadrant, and that'll give me my direction. So I want to take the inverse tangent, because I have an opposite. My opposite is negative 301.2. I have an adjacent, negative 193.5. And believe me, I cringe inside writing that down because I did write down a negative divided by negative, which I really don't like to do. So when I type it in the calculator, I'm lazy, so I'm not going to bother because a negative divided by negative is a positive. So 301.2 divided by 193.5. I'm still in degree mode, so I'm okay. And that's going to give me 57.3. So that means this angle is 57.3 degrees, which is slightly further beyond the 180. So I have to add that to 180. So my overall direction is going to be 180 plus that, so that I think is about 237.3 degrees, which makes sense because it is in the third quadrant. And so we have that. So notice the setup. So while you're writing this down, is exactly the same idea. What's your magnitude? When you deal with modeling, that's force or speed. What's your direction? Well, be very careful in direction because direction is always measured from standard position. So you might find theta from inverse tangent, but that's the angle in the reference triangle. To find the direction, you have to make sure you do it from standard position from 0 degrees. So there is your modeling problem for vectors. Thank you for watching our video. Please remember to both like and subscribe so you can get future updates when we make new ones. And remember to support our advertisers who make videos like this possible. Today's video was presented to you by Slide Rule. That's right, Slide Rule. Ever forget your calculator at home? Ever have the battery die in the middle of the test? Have no fear, Slide Rule is here. That's right, performing calculations is as easy as a slide. Need to find the side of an angle? Slide Rule. Need to find the log of a number? Slide Rule. You can use Slide Rule for all of your calculations in your math classes. And if you act now, they will throw in this wonderful carrying case to keep it safe. Just slide it in, and it'll fit in your pocket. Psst, psst. What? What do you mean no one uses slide rules anymore? Looks like we lost our advertisers, but hey, still like and subscribe.